previous video I showed the latest dashboard for the backup temperature monitoring, and this is working well. Now I have found using the EEPROM to store the values and limited to integers rather than floating points. There is a way around this which is a bit more complicated, but I've decided I'm happy to keep a 1 degree variations in temperature within the tank. This will only ever be used if there's an issue with the main DD temperature controller which fails for some reason and I have to turn that off. This will automatically kick in, so if heaters fail on that controller, this is there as a safeguard only. So obviously on my Github page, under the ESP32 software and temperature control, you'll see here the different variations of the program as I've developed it along the lines, and the final one is this one, version 1J, and that's what we'll probably take a look at shortly. If you go into it, you'll see I have got a readme and I'm basically trying to explain some of the more complex parts of the code. Now, rather than try and talk through this will all be documented here, so hopefully you will be able to read up and find the information you require, rather than me doing long-winded videos talking your way through code. So here in the temperature monitor flow, here you'll see I have changed the names of the MQTT topics. This was to get rid of the spikes from the previous sketch that I'd had running on the ESP32. Again, most of this is very much similar. I put this text node in here just to put the explanation of what you are seeing within the EEPROM restore, and that I felt was needed to give a bit of explanation. This node here is new. Now this one is what is being used to send the new variables to the ESP32 to alter the threshold statuses within that program, so I don't have to actually connect up to the ESP32 using a USB lead. Inside this node, you'll see here I've got a maximum temp setting, press the tab, so that's the description. And then because you are going to be using text, the mode is text input. I put a delay of 5 seconds and the topic is topic. So basically when you put the data into this, you have to type it in and press the tab key or the enter key. Once you've done this, obviously here I've got a debug node. This is for while I'm working within the program, but it's also handy to have. It then sends that message to backup max setting, which then alters the code within the ESP32. And then I just have one here for setting the min value, and that sends it to the topic backup min settings. And finally I've created this small flow here which gets its data from the ESP32 under the topic name feedback topic, and that basically just sends a message back to say yes, I've changed the min value or max value, and I send that then to this node here on the dashboard, which hopefully that makes sense. So that's the node red part of it. If you would like to see more details on this flow, please comment and I will look possibly at covering this. But I will also make this flow available on the Github so you can actually download it, bring it in to your Node-RED to see exactly what I have done with them. Even though it won't work on your Raspberry Pi, you can see how I've done it. Here's a brief look at the code, which is version 1J. And I'm not going to go into too much detail because a lot of it is basic ESP32 Arduino IDE coding. It does use C and C++, but you can see here I'm setting the values here. Now even though I've set it as a float here, this will get ignored when it pulls in the EEPROM, so really I need to change this in the code. The reboot timer here is set wrong because I want this to reboot at the moment for testing purposes every 2 days, when it eventually will be either to 28 days or it could even be pushed to 50 days. This is to do with the Millie's rollover. And the code, even though it looks complicated, if there's any of these functions you're struggling with, let me know, because I am going through the code and adding it to the Github as a description. But if there's anything that particularly you're interested in, let us know. But as you can see, I think at the moment the code is a total of 191 lines, and the main loop part of it is basically this bit here where it pulls the temperature at a certain millipoint, which is the interval time, runs that bit of the code, it goes to the function, does what it needs to do. And then we also have this one here, which is the publish the heater state. We run this code here, which control heat, which is another function. This bit here is looking to see if we are actually connected to MQTT. If we're not, reconnect. And then finally, we've got the MQT client loop, which we need. And then we've got the ESP reboot timer. That's the code. And the next ESP32 module, which is the main temperature one, is actually under testing at the moment, and this is just monitoring 3 DS1820B sensors, and the sketch was similar to what I already had using the Raspberry Pi, but obviously now I'm just using the ESP32 for the data collection. So it's a very basic and simple flow, and this shows up now in here. So at the moment this has only been running since 10 o'clock last night. Hopefully you can see this is coming along, and the code on this one is already on the Github as version 1 under the name main. So you can see how this has been done. Quite a simple sketch. May get more details added to it as I start to play with it and decide, well, do I want it to do any other things? But the temptation is to try and keep each module simple, so it's easy to work with. And you must remember, all these modules are meant to run fail-safe. The main aquarium, if the module fails, it does not affect how the aquarium runs. It's just allowing me remote access to see what is going on. Anyway, thank you for watching. See you in the next episode. Bye.